Hello everyone, welcome to the 11th lecture in this series. In this lecture, we are going to study about circular linked list. This is actually the third type of linked list which we have been discussing from the previous 2 or 3 lectures. In this lecture, we will be learning about both circular single linked list and circular double linked list and the operations that are possible on a circular linked list. So, this is the overview of this lecture. First, we will see an introduction to what circular linked list is. Then we will be seeing what are all the operations that are permissible on a circular linked list. Then we will see how to do operations on a singly circular linked list, how to do it in a doubly circular linked list. Then we will be seeing the routine for doing traversal in a circular linked list. Then we will be discussing what are all its advantages and disadvantages, then a summary and some questions to test our understanding of the concepts. So, circular linked list. So far we have studied about single and double linked list and the various operations that can be performed on both the types of lists. The circular linked list, it is much similar to the single linked list which we have seen before. In a singly circular linked list, the only difference is instead of last node having a value of null in its address part, it will have the address of the first node of that list, right. So, here it offers us the flexibility to move to the nodes to enter into the list again from the last node of that list. Thereby, we will be able to spin across the elements that are part of a list. And in case of a doubly circular linked list, there is we make two other modifications, that is the first node will have the address of the last node in its previous part instead of having a value of null, and the last node will have the address of the first node instead of having the value of null. So, usually in a doubly linked list, every node will have 2 pointers, previous and next, and in a doubly linked list the first node's previous part will contain a value of null and the last node's next part will have a value of null. But in case of doubly circular linked list, the last node's next part would contain the address of the first node and the first node's previous part would contain the address of the last node. So, that is the variation of a circular linked list from single and double linked list. So, these are the operations that are done or that is permissible on a circular linked list. We can create, we can traverse, we can do insertion at the beginning or at any position in the list, and we can even delete the last node from the circular linked list, and we can delete nodes at first, middle and last position just as we did with single and double linked lists. Then we can count the total number of nodes in a list. We can reverse the contents or elements from a list. Apart from that, we can even think of doing a searching operation on a list or doing sorting or doing some modifications to specific element on a list. So, now let us see how to do insertion at the first position in a singly circular linked list. So, in a singly circular linked list, if I delete the first node, much of the things are similar to what we have seen with single linked list. The only variation is that in a circular linked list, the last node would contain the address of the first node, right. So, if I insert a new node in its place, then the last node's next part should contain the address of the new node, right. So, that is what we have to do or we have to take care of. So, here as we are talking of insertion, the very first step which we have to do is we have to allocate memory for the new node, right. We make a call to we invoke a malloc function, we get the memory allocated for the new node, and as such, since it is a single linked list, our node will have two parts, a data part and a next part, right. We put up the data in the data part and we initially put up a value of null in the pointer's next part, and here we have used another pointer named PTR to point to the new node, right. So, here the next step which we do is that hereafter this node named PTR should be the first node of that list and head should point to it, right. So, we should make head to point to PTR, that is one of the things which we have to do. And apart from that, what we have to do is we have to do some modifications in the last node's next part, right. So, first step which I do is that I move to the last node in that list, right, and I make or set its next to contain the value of PTR, right. So, thereby the last node would point to PTR, right, and after that I should check I should make PTR's next to have the value of head, right. This is because hereafter whatever being this node is going to be, PTR is going to be the first node in the list hereafter, and so far whatever was the first node, its address is available in head, right. So, I take that and put it in PTR's next part. So, PTR's next part would contain the node, right, that was pointed to by head, and hereafter this node would become the second node of that list after we make this assignment. So, here you see the old link is removed and we set up a new link from new node to the second node, right. And the last step which we do is that hereafter this node should be the first node in that list, and so we make an assignment as head is equal to PTR, right. So, actually we have made 3 pointer changes. One is that we have made the last node's address part to contain the address of PTR. Then we have made the second node's address to be available in PTR. Second node's address is already held in head, we have moved it here, and finally we have set up PTR to be head, right. So, we have made 3 pointer modifications in order to insert a node at the first position in the singly circular linked list. Now, let us see how to do insertion at the last position. So, here you know the last node usually contains the address of the first node. Now, we are going to insert a new node there, and after that insertion the new node's next part should contain the address of the first node, right. So, here that is what we have to do. As such, you know, as we studied with the single linked list, in order to do insertion at the end, first we have to navigate to the position of the last node. For that we will be doing a traversal operation. We will be checking whether the node's next part contains a value of null. So, we start from the first node, we check whether its next part is null, it is null here. So, we move to the next node. So, we have used the pointer named temp. So, initially we assign temp to take the value from head, thereby temp will be made to point to the first node. We check whether its next part is null. If not, we advance temp by 1, or temp we move temp to the next position by saying temp is equal to temp's next, thereby we moved here, right. So, in our case earlier this list had only 2 elements, right, and now we are adding the third element to the list and that too at the last position. So, while we do traversal, earlier this node would have had the value of null in its next part, and so we would stop here, we will stop traversal at this position. Now, we have to add a new node next to the node being pointed to by temp. So, here we have to do the assignment as temp's next is equal to PTR. So, if we add up that statement, then the new link between temp and PTR would get created. And apart from that, we should make the new node's address part to contain the address of the first node of that list. So, if I do that statement first, that is temp's next is equal to PTR, then I would miss up the address of the first node of that list, it would get overwritten, right. So, I will not do that first, rather I would preserve this address. So, first of all I take address from temp's next, right, and that should be put up in pointer's next part, right. So, here there is one more option to get the address of the first node. You know the head pointer named head also contains the address of the head node, right. So, I could either take the address of the first node from temps next, or I could take it from head. So, here we have gone with the second case, that is pointers next is equal to head, means I am putting the taking the value from head. Then I do the next step, that is temps next contains, I mean I point to the next node, which is PTR. Thereby you could see that old link which is shown in dotted would get vanished, and the new link which is shown in thick line would get created with the help of these two pointer manipulations. Now we see how to do insertion at the first position in a doubly circular linked list. So, here you could see we have omitted how to do insertion at some arbitrary position, just because insertion at any arbitrary position is the same if you do for single linked list as well as you do for single circular linked list. That is why we have not considered that case. Now, we see insertion at the first position in a doubly circular linked list. So, first node we have to insert a new node to the first position. So, the first step we have to do is we have to allocate memory for the new node, and here I have made use of a pointer named PTR to point to the first new node that has been created just now, and initially its previous position and its next position would contain or would be assigned to hold a value of null, right, and we put up the data in the data part of the named node pointed to by PTR. Now, this node that is pointed to by PTR has to be the first node of that list. So, I may have to do certain pointer modifications. So, the things which I have to do are head should point to this node, right, and this node should point to the node that had been first so far, and then the last node's address part should contain the address of the node named PTR, because this is going to be the first node of that list hereafter. So, we have to do all these three things done. So, the first step which I am doing is that I am setting temps next to contain the value of PTR. So, the temp is the last node of the list at this point of time. So, first of all I should decide which is the last node in that list, right. So, I can do a traversal, or just because this is a this is a double linked list, and the first node's previous part would contain the address of the last node, right. Just because it is a doubly circular linked list, the node that is the first at this point of time will its previous part would contain the address of the last node of that list, right. So, that is my temp. So, I could straight away get the address of the last node from the first node just by looking at its previous part. So, thereby I have fetched the address of the last node. Now, I want the last node's next part to point to the new node, right. The new node is the one that is named as PTR. So, that is what I am doing as the first step, temps next part to contain the value of PTR. So, thereby this link would get set up, right. And then the next thing which I have to do is PTR's previous is equal to temp. So, here this is what I have done. This is the node named PTR, right. I should set up its previous to have the value of temp, because hereafter this is going to be the first node and its previous should contain the address of the last node, and our last node is the one which we have named as temp, right. So, we set PTR's previous is equal to temp, which means the first node's previous part would contain the address of the last node. Then we set we move to the PTR's next part. So, here this node is going to be the first node hereafter, and its next part should contain the address of the subsequent node, but subsequent node's address is already available in head. So, I use that thing. So, I set PTR's next is equivalent to head. So, with this assignment the second node's address will get moved to first node's next part. After that I should set head's previous is equal to PTR. So, head is the one here, right. So, this node's previous part should contain the address of the first node, right. Second node's previous should contain the address of the first node, that is what I am doing. Heads previous is equivalent to PTR. So, this also gets done, and finally, we set up this node to be the head. With this one assignment, head is equivalent to PTR. So, we have made actually 5 pointer changes done here. First is the last node's address part is having the address of the first node. How I get the last node is that you know very well, first node's previous part straight away contains that gives me the address of the last node. So, I can even put up one statement above as heads previous is equal, temp is equal to heads previous, that would give me the pointer temp to be fixed at the last node of that list. Then I set up temps next to have the address of the new node, which is PTR. What I do next is I should make assignments for PTR's previous and next. So, PTR's previous should contain the address of the last node, and that is my temp here. So, that is what I have done here, and PTR's next should have the address of the second node. So, second node's address, no pointer is there to point to the second node, but head is having the address of the second node because it was the first node earlier. So, I am doing this previous next is equal to head, and then second node's previous part should contain the address of the first node, right. So, I do not have any other pointer other than head to point to the second node. So, I say heads previous is equal to PTR, and finally, I should make the new node as the first node of that list, for which I do the assignment as head is equal to PTR. So, upon doing this 5 pointer manipulations or modifications, I will be able to add one node to the first position in a doubly circular linked list. Next, let us see how to do insertion at the last position in a doubly circular linked list. So, here just because it is insertion, I should add up create a element, create memory or allocate memory for the new node, right, and then I have to insert it at the end, right. So, certain pointer modifications we may have to add up. So, let us imagine that PTR is the new node that has to be added up to the last position in the list, and temp is the node, it was the last node earlier, right, and temp's next part actually contains the address of the first node of that list, and alternatively head also contains the address of the first node. So, I could either fetch it from here or fetch from head. So, that is one thing I should add to previous pointers next part, and then when I talk of pointers previous, it should contain the address of temp, right. So, straight away we have temp, so we can use it, and then when I talk of first node, it should contain the address of the last node, right. So, its previous part should contain the address of the last node, which is going to be PTR in our case now, and then PTR's next, which is the address of the next part of the new node should contain the address of the first node. So, which is available from head, right. So, these are the changes which we have to do. So, first is temps next is equal to pointer. So, we make this happen, that is last node is positioned at the right place, and then we set pointers previous is equal to temp, that is also possible. So, we have set up these two links. Now, these two nodes point to each other, and then we come to the last node. In last node's previous should contain the address of heads previous should contain PTR, which means the first node's previous part is made to contain the last node, and pointers next part is made to contain the first node, which is available in head, right. Upon doing these 4 pointer modifications, we will be able to add up a new node to the last position in a doubly circular linked list. So, having seen how to do insertion in a circular linked list at first and last positions, both in circular singly linked list and circular doubly linked list. Now, let us see how to do traversal operation on a circular linked list. So, here what you see is the routine for singly circular linked list. So, you could see that very well from the node definition itself. It contains one data and one self referential structure named next, right. So, it is a single linked list. So, here you could see we ask from the user how many number of nodes to be created, and then we make a call to create list and display list function. So, this is the routine for creating a circular linked list. So, if it is going to be a one node list, then we will allocate memory for one node, may name it as head. We put up data in the data part of the node named head. We set up its next part to null, and then we set up another pointer named previous node to point to the first node, which is being pointed to by head, right. So, this is for doing further, this is for doing or adding further nodes to the circular linked list. And if suppose we want if the our n value something greater than n, then we will be ending up here. We will be allocating memory for as many nodes we want during every iteration. We get data from user during every iteration, and we put up data in the data part. We initially assign a value of null to its next part, then we add appropriate nodes here. That is for the current nodes next part, we will be putting the new node, right. And hereafter the previous node, new node would become the previous node, right. Thereby, we will be able to add as many nodes to the list. Every time we add up a new node at the end position, that is what we mean here. So, once we are done with creating that many new nodes we want, the last step which we have to do is we have to put up the address of the first node in the last nodes next part, right. That is the last step which we do. Only then it makes this list to be a circular linked list. So, that is the last step which we do. In the last nodes next part, we just put the value of the head, which is head contains the address of the first node, right. That is put up in the last nodes next part. Thereby, we say that we have successfully created a circular linked list. And if suppose we want to do a traversal operation on a circular linked list, then we could do it very well. First condition is that we check whether the list contains some elements or not. If head is null, the list is empty. Otherwise, we set up a pointer named current to point to the first node in that list, and every time we advance current by 1, which is current is equivalent to current's next. So, we will be keeping on doing this by having a value of by doing n number of times, just because very well the last node contains the address of the first node, right. So, here our stopping criterion would be whether current is not equivalent to head. So, when current is equivalent to head, it means we have reached the last node just because it contains the address of the head, or we have reached the head node once again, right. So, we will be doing that till we reach the first node of that list. So, that is how we do traversal operation on a circular linked list. So, having seen some of the operations on circular linked list, now let us see its advantages and disadvantages. The first advantage is that a circular linked list, we can do traversal from any arbitrary node, right. Say even if I am in the third position in a list, I can very well reach say imagine that I have 5 nodes in a list, I am in the third position, I do traversal from there, right. Then I can very well reach third, fourth, fifth, and once again I can come back to 1 and 2 just because it is a circular linked list. So, we say that traversal can be done from any position, and when we want the list to be accessed in a circular fashion or in just like a loop, then circular linked lists are very helpful. And if it is a single linked list, very well we can only move in forward direction alone. But if the same list is implemented as a singly circular linked list, then we can very well move to the previous elements as well in a list just by after reaching the end of the list. From the end of the list, we can once again move to the first position in that list, and so that makes traversal to previous element also possible in case the list is implemented as a singly circular linked list than a single linked list. And there are certain disadvantages as well when we have when we see with the circular linked list. One is that it is a bit complex than singly linked list, and when we attempt to make a reversing operation, reversing all elements from a list, then in case of circular linked list it is going to be a bit tedious, just because instead of last node's next part being null, it will have the address of the first node, right. So, we need to keep track of it carefully. And if suppose we are not traversing the circular linked list carefully, ultimately there is a chance that we end up with infinite loop. So, we have to be careful, and like singly and doubly lists, linked lists, circular lists also does not support random access, right. We can't straight away access any specific element as we do with arrays. So, it is not possible with circular linked lists as well. So, it is one of the disadvantages of circular lists. To summarize, circular linked list is a very useful data structure, and in case of singly circular linked list, it offers us a chance to move to the first node of the list from the last node, just because the last node contains the address of the first element in the list. And traversal is possible from any node in a circular linked list, and in specific with respect to single linked list, there is no way to reach the previous element in a list, whereas in case of circular singly linked list, there is a way to reach the previous element in a list. And insertion, we may have to do appropriate pointer modifications in order to add a new node to the first position or at the last position in a circular linked list. And similarly, with respect to deletion also, we have to do additional pointer modifications if suppose we do deletion at the first as well as at the last position in a circular linked list. And plenty of advantages are there with respect to circular linked list, especially in terms of scheduling, in processor scheduling, round robin scheduling is very often used. And with round robin scheduling, consider that we have 5 jobs and we have one processor, and imagine that every job should take its turn to run on the processor. Then in case of round robin scheduling, every process or job would have, would take certain amount of time with the processor, right. But the available processing time should be spinned up between all the available jobs, right. But every job should be given a fraction of the processor time during every iteration, right. In that case, holding the jobs in a circular list would actually help, and thereby the list, every job would get its turn to run on the processor every time. So, with respect to scheduling, with respect to buffering, circular linked lists have many real time applications, and in case of multiplayer games also, circular linked list has proven to be the best data structure and is widely used. So, having studied the concept of circular linked list, let us now check our level of understanding of the concepts which we have learned so far. The first question is, how does the structure of a circular linked list differ from a regular linked list? So, in a regular linked list, the last node's address would be null, and in case of circular single linked list, the last node's address would contain the address of the first node in that list. And what is the main advantage of a doubly circular linked list over a single circular linked list? So, the advantage of any double linked list is that we have 2 pointers, and with the help of that every node has 2 pointers, and that gives us the flexibility to traverse in both the directions. And just because it is a doubly circular linked list, we can navigate to any node in a list from be it forward direction or in the backward direction. And then how do you identify the end of traversal in a circular linked list? So, as you know, the last node's address would contain the address of the first node. We could make a check of the next part of every node. If the next part of a node contains the address of the first node, then that happens to be the end of the traversal, right. And what are the steps required to insert a node at the end of a singly circular linked list? If I want to add a node as the last node in a singly circular linked list, first of all I should find the last node in that list. For that, what you can do is you can check the node's address part whether it contains null, right, or you can check for a node whose address contains the address held in head, right, that is going to be the last node. And we will be creating or allocating memory for the new node and then attach it at the end by doing one pointer modification. That is, the last node's next should contain this newly created node, and the newly created node's address should contain the address of the head, right, that is the first node of the list. And why circular linked lists are well suited for applications like round robin scheduling. So, in round robin scheduling, the available processing time should be equally shared by all the processes or jobs, right. So, a data structure like circular linked list will help you to spin between the available number of jobs, and so we say that circular linked lists are best suited for implementing round robin scheduling. I hope you are now thorough with the concepts of linked lists, be it single, double or circular linked list, and the various operations which we can do on it. And of course, linked lists and arrays form the basis for all the implementation of all the data structures which we will be learning in the further lectures. And so, I hope you are all thorough with the concepts.